Welcome students. During this class, we will study about a law which is called Hooke's law, and this law explains the relation between stress and strain. So, starting from the man, that is Hooke's law. He was a scientist of 16th century. Robert Hooke discovered a law for elastic material. Hooke's law achievements were extraordinary. He made the first powerful microscope and wrote the first scientific bestseller of micrographia. So, elastic and plastic behavior. I have already discussed during one of the classes. If a material returns to its original size and shape when you remove the force stretching or deforming it, a reversible deformation, we say that the material demonstrates elastic behavior. If you are holding a plastic scale in your hand, you apply a force, and after application of the force, you bend that scale. Basically, you have changed the shape of that scale. Up to this limit, you remove the force and the scale goes back to its original shape. This type of behavior or property is elastic property. And its behavior is elastic behavior. But you have not stopped at that limit. You have applied force, applied force, checked, it come back. Again, you checked after application of the force, it come back to its original form. A time reaches where beyond that, if you apply more force, then the scale is broken, and after removal of the force you are unable to move the scale back. That type of the behavior is called plastic behavior, and that limit is basically called plastic limit, beyond which uh, you can't see the scale at this original state before the application of the stress. So plastic material is one that stays deformed after you have taken the force away. If deformation remains irreversible after the forces are removed, then it is sign of plastic limit. Take a spring as well. If you apply a force on a spring and release it, it will move back to the same state. But at a stage, if you apply too much force on a spring, it is stretched after the limit. If you remove the force, the spring is not regaining its original shape. So that is called plastic behavior, and that limit was plastic limit beyond that you were unable to move it back. If you apply too much big force on a material, it will lose its elasticity. So Hooke's law discovered that amount of a spring stretches is directly proportional to the amount of force applied on it. Another statement is stress is directly within elastic limit. Stress is directly proportional to strain. You apply more stress, more strain is produced. You apply more stress, more strain is produced. But you release it, it will come back to its original state. So within elastic, this is the elastic limit. The object is regaining its original state. But if it is not regaining, that is not the limit where you can't apply the Hooke's law. You only can apply the Hooke's law within the limit where stress is directly proportional to strain. Stress is directly proportional to strain within the elastic limit of the body. This means if you double the force, its extension will double. And if you triple the force, the extension will triple, and so on, like the case of a spring. And then what happens? This is F. You can write the Hooke's law in this formula, that is F is equal to Kx. And this is basically, if you write it mathematically, and it is written like this: F is directly proportional to strain produce X. More you apply the force within elastic limit, more the strain you will be able to produce, more the extension you will be able to produce, but within elastic limit. So this F, if you remove the proportionality sign, this F, that is equal to Kx. This is the most famous equation for Hooke's law. F is the applied force in Newton, X is the extension in meters, and then K is the spring constant. This K have different value for different types of the materials, but normally we take one, and that is, and we are given for the constant spring constant of that value. Depending on the material, the K values varies. K is a spring constant Newton per meter. The extension K, del x delta x is sometimes written or del L. You find the extension from del x is equal to stretch length, original length. You measure the length before application of the force, say that is 10 centimeter. And after application of the force, say it becomes 15. So you will subtract these two, that is 15 minus 10, that 5 centimeter is basically extension produced after the application of the force. So here it is, this is an experiment. You see you are using different weights hanging with the help of slotted weights, and this is the scale pointer. With the help of the pointer you increase the weight, the pointer will move, extension will move, and you draw. These are the different types of the weights taken to perform some experiment to see. Here on x-axis you take extension, on y-axis you take force, and you will see with the increase of the force, the extension also increases, which shows that there will be a straight line between extension and force. This straight line shows that we increase the stress within elastic limit, we increase the stress, the strain of the extension, which is measured with the help of scale, also increases. This proves the Hooke's law, and the shape of the graph will be a straight line. Whenever you are getting straight line, this shows that there is a relation of proportionality between these two quantities, stress and strain. It can happen only in case of a within elastic limit. But if the spring breaks, then the shape of the graph will no more be a straight line, but it will be bending like this. If it bends this limit, after the straight line will start the plastic limit, after which you will be unable to bring the spring back to its original state. With an elastic limit, Hooke's law is applied. When Hooke's law is applied, you are getting a straight line. When you are getting a straight line, you are able to understand. So here it is, you have increased 2 Newton, then you are getting another block. So at the end, if you see with the increase of the weight, you are getting another straight line increasing and increasing. You move up to the 6th Newton, you will see that within spring, if you remove 4 Newton force, the spring will move back to the original state. This is basically elastic limit. So more you increase, more you will be getting. So if you see after 4, 1, 2, and 3, and 4 means 4 Newton. When you apply 5 Newton, the graph is no more straight line. It means the deformation is produced in the spring. It is not moving back to its original state. The elastic limit can be seen on the graph. This is where it stops obeying Ohm's law. Straight line, where the straight line ends. This is the point where the Hooke's law ends. It is applicable only when the stress and strain are directly proportional. Up to the 4 Newton, if you have removed the weight, this spring will move to the original state, which was before applying 1 Newton force. But when you have applied 4 Newton force, this was the limit for this. Every material have its own limit, and you will judge with the help of experiments. This spring have only 4 Newton limit. After 4, if you increase the weight up to 5, it will not regain its original shape or size. So that's why this is called Hooke's law limit. So here it is. These are the two. When you have increased the weight, the graph is not a straight line after this. So this is the limitation. So here it is elastic limit. The point elastic behavior. This one is elastic behavior, after which the object is not regaining its, this is the load, and this one is the extension. If you look at below the elastic limit, we say that the spring is showing elastic behavior, the extension is produced to the force, and it will go back to its original length when we remove the force. I have given you example of up to 4 Newton. Beyond the elastic limit, this is another important point to remember. This one was within a Hooke's law, elastic limit. Now beyond the elastic limit, we say that it shows plastic behavior. This means that when force is applied to the deform, the shape, it always deform, it stays deformed when the force is removed. Spring is stretched, it is unable to move back and we further apply the force on the spring. So this is permanent deformation produced. When a permanent type of deformation or limit beyond which the permanent deformation is produced means after removal of the force, if you move back, if you see this one, you have you are permitting or you are hanging these weights up to 6 Newton. And after application of hanging 6 Newton, the spring is not moving back after removal of 6 Newton force. So this is basically permanent deformation produced. And beyond that limit, within that limit, the spring was attaining, regaining its original shape or size, that was plastic limit. And beyond that limit, when you have applied a furthermore force equal to 6 Newton, the spring is not regaining its original shape. This is basically permanent deformation. This limit was called plastic limit. In some of the cases, the object breaks. So here is an example. Weight of 8.7 Newton is attached to a spring that has spring constant. You are given values of constant. How much will this spring stretch? You are asked to calculate x. So given are, here it is 8.7 Newton. So value of K is given 190 Newton per meter. Unknown is extension, and then equation is F is equal to Kx, and you will calculate here. F is given here. Value of K spring constant is given for the material. It depends with the material. X is you are asked to calculate, and this X is equal to, if you take X from this equation, this X will be equal to F divided by K. So here is the formula to calculate extension. And this was the example to solve problems related to Hooke's law, when you are given force acting, force applied on the spring to produce certain stretch, to produce such an extension, and the value of K spring constant is given, then you can calculate. It can be used in different ways. If you are asked to calculate a spring constant value, then force given applied will be given and extension produced is given. Then by using this relation, you can calculate the value of constant of that material as well. So with this, our class ends. Hope you people have understood. For